So we did the tables, we filled out the tables, and we figured out that the first one, right? If I do 1 to the power of a half, 4 to the power of a half, 9 to the power of a half, 16 to the power of a half, we know that we're square rooting, right? So it's the same thing as saying square root of 4, square root of 9, square root of 16, right? And then I got 1, 2, 3, 4. Yes? Okay. Now, when I raise the base to the power of 3 over 2, do you notice anything, any relation between the second column and the third column? Okay, let me ask you a question. What is 2 to the power of 3? Find out on the calculator for me. 8. So look here. That's 8, right? What's 3 to the power of 3? What's 4 to the power of 3? Okay. Now let's look here. So what I'm doing in this case, I'm taking the answer from this here. So after I square root it, right? I'm taking the answer and I'm raising it to the power of 3. I'm taking the answer, raising it to the power of 3. Taking the answer, raising it to the power of 3. And I ended up getting the same answer as if I did 4 to the power of 3 over 2. Okay? So basically, what I did first is I did to the power of a half, and that gave me 2. Right? 4 to the power of a half, and that gave me 2. Then I raised that 2 to the power of 3, and it gave me 8. I did 9 to the power of a half, and that gave me 3. Then I took that 3, and I raised it to the power of 3, and that gave me 27. So I took my bases, square rooted them because my denominator is 2, and we know that if my denominator is n, then we're doing the nth root, right? So basically what I did is I square rooted them because my base is 2, and then I raised them to the power of the numerator. Let's see if that's the same case with respect to the last column. Okay, eyes on the board for a minute. So this column here says A 5 over 2, right? So basically, if I'm looking at this, A, I have a half times 5, right? If I have a half times 5, that's the same thing as 5 over 2, right? So I'm square rooting the A first, and I'm raising it to the power of 5. So 4, what's the square root of 4? Square root of 4 is 2. Then raise the 2 to the power of 5. What do you get when you raise the 2 to the power of 5? You should be getting 32. Is that what you got? Now, I'm going to take 9. I'm going to square root 9. What do I get when I square root 9? 3. Raise it to the power of 5. What are you getting? 243. Right? So, the base, the denominator is causing the root, and the numerator is causing the power. That's going to happen in this case as well. Right? So what I'm doing is I'm square rooting this, then I'm raising it, so I get this answer right here, and then I'm raising it to the power of 2 or to the power of 5. Okay? So 1 to the power of 2 is 1. 2 to the power of 2 is 4. 3 to the power of 2 is 9. 4 to the power of 2 is 16. So my first step is I square rooted because I have a denominator, sorry, I cube rooted. You guys should have fixed that for me. I cube rooted, okay, because my denominator is 3, right? Then I'm raising it to the power of the numerator. Now, look here. 1 to the power of 5 is 1. 2 to the power of 5 is 32. 3 to the power of 5 is 243. 4 to the power of 5 is 1024. Okay? So what's happening here is the following. So a to the power of 3 over 2 and a to the power of 5 over 2 are equal to a to the power of half, right? So first I do a to the power of half raised to the power of 3 and 5 respectively. So basically, a to the power of 3 over 2 is the same thing as doing a to the power of a half and then making it to the power of 3. When you're done writing this, look at me, please. What do we know about power to the power? We learned yesterday when I have power to the power, what do I do with them? When I have power to the power, what do I do? Multiply, right? When I have, and this is what I have here. I'm raising it to the power of a half, then I'm raising it to the power of 3. Okay? So, raised to the power of half, then raised to the power of 3. I have power to the power. If I multiply 3 times a half, multiply 3 times a half on the calculator, what do you get? In fraction, I don't want the decimal. I don't care about the decimal. What's 3 times a half? 3 over 2. Right? So, that's what I started with. I started with a 3 over 2. So that's the same thing. Again, I'm going to repeat myself. It's raising it to the power of half, then raising it to the power of 3. Okay? So, if I have a to the power of a half to the power of 5. Again, power to the power, what do I do with my exponent? Multiply them. What's 5 times a half? Now, what would I say about the 2 over 3 and the 5 over 3? So a 2 over 3 and a 5 over 3 are equal to what? A to the power of 1/3, right? Raised to what? Raised to the power of 2 and 5. Am I missing something here? Respectively. I'm missing a 5 here, by the way, guys. How would you write a 2 over 3 as a power to the power? So what do I raise it to the power first? 1 over 3. What power do I put outside? Can I have? Here, I is here. So, a2 over 3. I raise it to the power of 1 over 3 and then to the power of?
Use multiplier.
But what would I put outside here?
30.
2.
2.
2. How about this? What would it be? A to the power of? Guys, it's going to be exactly the same thing as this. A to the power of 1/3. And then to the power of y2. What do I have here? 5. Okay. How can I write a to the power of 1 over 3 as a root? What would it be? The root of what? So if I'm writing a to the power of 1 over 3 as a root, what do I write that? How do I write that? What do I put here? 3. So that's going to be the cube root of a to the power of, no, but the cube root of a is a to the power of 1/3. They're the same thing, okay? To the power of 5. So that's the same thing as writing this, right? So look what's happening. The denominator, where is it going to in the radical format? Where does the denominator go? Where do you see a 3 in the radical format? In the root. You see it in the root, right? Because it's a cube root. And where do you see the numerator? Where do you see that numerator? Outside the bracket as a power. Okay? Is this going to always happen? Let's see here. That's the same thing as writing cube root of a. I'll write it here. Cube root of a to the power of 2. So that power of 2 is on the outside. And that denominator, which is to the divided by 3, is the cube root. Okay? So, if I see something that's written as a to the power of m over n, where does n go?
N goes inside.
In the root. So that's the nth root of a to the power of n.